Whoever came up with the game of tennis can't be very good at math. I mean, who counts love, 15, 30, 40, game? It just doesn't make sense. How likely is it that the best player is actually going to win in their category? In this house, we watch a lot of tennis. And in tennis, wow, a tournament, you've got, well, to win a game, you have to win at least 4 points. Remember that weird numbering scheme. You have to win at least 4 points by a margin of 2. And in order to win a set, you have to win at least 6 games by a margin of 2. And in order to win a match, you have to win the majority of 3 or 5 sets. But you know, they've also got this single elimination tree, and usually there's 7 layers to get through. How likely is it that you're actually going to end up with the very best player being the one that takes the top prize? Well, let's just keep it simple for this particular demonstration and only focus on a single game. And as I said before, and we're talking about tennis, a single game, what you have to do is win 4 points, at least 4 points, by a margin of 2. And so the scoring goes something like this. 0 is called love. 1 point, that is 15. And 2 points, that's 30. And 3 points, that's 40. And then 4 points, there's the winning point number, that is called game. Let's see if I can write here. All right, that is called game. Now there are 4 ways to win a game. You can win game, love, right? So you got 4 points, your opponent got 0. You can win game 15, you got 4 points, your opponent got 15. Game 30, you won all 4 points, they only won 30. But we've got a problem with this 40. Remember, I said you have to win by 2. And so if both players get to 40, then what you've got is deuce. And deuce basically means that we're even, 40-40. Now, whoever wins the point after that has the advantage, right? But they can't win on the advantage. They have to win on winning the next point. So this is going to be really difficult to figure out. Well, not really difficult, but it's going to be a little bit complex in order to figure out the odds. But the key is we've got a lot of data on here. The tennis players at the top of their game, they have played a lot of matches, and just about everybody has matched up with just about everybody else. And so we have a lot of data that records the probability that they're going to win a single point. So if we have a probability, if we have a measure of a probability of a particular player winning a point, and I'm going to identify this with a lowercase p because I'm going to be writing this a lot. I really want to have a shorthand. Can we figure out from this probability of them winning a point whether or not they're going to win the game? And from that, we should be able to figure out whether they're going to win the set. And from that, we're going to figure out whether they can win the match. We're going to just stick with game. Now, there is a problem with this particular demonstration. This demonstration is going to assume a consistent p for any game. Problem is that p varies throughout the game. For example, some players played longer games better. They have better stamina than other players. It doesn't take into account injuries. It doesn't take into account changes in weather. It doesn't take into account whether you're serving, or doesn't take into account which side of the court you are on. So we are actually taking quite a liberty by having a consistent p. So we're going to talk first about the probability of winning game love. In other words, the one player, and we're just going to say you have got all 4 points and your opponent got 0 points. Well, how likely is it? What is the probability that we did this? Well, the probability that we did this is going to be the probability that you won the first point, and the probability of the second point, and the probability of the third point, and the probability of the fourth point. And remember, and was multiplication. So what we've got is p times p times p times p. 4 times. And that will give us the probability that if you have a probability of P for winning a point, then the chance of you winning the game love, is P to the 4th. Let's put a number in here. For example, let's just go ahead and identify our P equal to, we'll give them just a little bit more than a half chance per point. Now, you may look at that and say, that's kind of low, especially when you're talking about incredibly good players. Well, when you're talking about incredibly good players and they're playing other players that are of their caliber, that probability is actually pretty reasonable. We're going to see the chance that they're going to win a particular game. So if we are looking at our probability of 0.55, then this is 0.55 to the 4th, which is equal to 0.915. 0.0915. So this is the probability that they're going to win game love. Now remember, this is not the only way that they can win, but if they win game love, that was the probability that they would do it. So let's just put up here somewhere, how about the probability of game love is equal to P to the 4th, and in the case of our example here, this is going to be 0.915. Now let's talk about the probability of winning game 15, all right? And what that means is that there were 5 points won, 4 of them by you and 1 by your opponent, that 1 representing the 15. Now, the question is which one of those, or how many ways could that happen? Well, your opponent could have won the first point and you could have won the next 4. Your opponent could have won the second point and you could have won the first and the last 3. The only option that's not an option for you winning 4 points and the opponent winning 1 point is you winning the first 4 points and they win the last point. Because whenever you won the first 4 points, game would have been over and you're looking at game love. Now, how many ways can this happen? Well, it happens 4 choose 1, because remember, once again, you have to win the last one. There's only one point that is predetermined, but we have to pick which of the first 4 points were won by the opponent. So that ends up being 4 choose 1. And as we know, there are 4 ways to choose 1 out of 4. So whatever probability we figure out for game 15, those probabilities, there are 4 ways that we could win game 15. So the actual probability of game 15 becomes 4 times, well, remember, you win the first point. In fact, you win 4 points, and your opponent wins the remaining points. Now, what's your opponent's probability of winning? Now, the overall sample space for this probability of winning a game is 1, right? It's got to be either you win or your opponent wins. So everything that is left from P ends up being your opponent's chance of winning. So that becomes 1 minus P, and that is the opponent's chance. And so we have 4 ways that you can win by game 15. You win 4 points, your opponent wins 1 point. There's your expression right there. And what we get is P game 15 is equal to 4 times P to the 4th times 1 minus P. All right? And if we substitute in the 0.55 for our probability of winning a single game, what we end up getting is approximately, and I should be putting approximately in front of these, right? Approximately 0.1647. All right, let's move on to game 30. Game 30, what does that mean? Well, just like with game 15, you won 4 points. The difference is this time your opponent won 2 points. Where did they win the 2 points? Well, just like in game 15, you had to win the last point. If you won 4 points before they won their second point, the game would have been over and you would have been able to have said that that was game 15 or game love. So once again, we're talking about the first point has to come from you. But Where in this case, 4 points you won, 2 points the opponent won, that's a total of 6. They have to figure out which 2 of the first 5 are the ones that they're going to win. So we have 5 choose 2 as the number of ways we could win a game 30. And 5 choose 2 is 10. So our probability of game 30 is equal to, well, we've got 10 of the ways that it can be done times the 4 points you're going to win. So you're going to win at your probability, p to the 4th, times, and then the points you're going to lose, 1 minus p. And 1 minus p, since we've lost 2 points, it's going to be 1 minus p squared. And we're going to go ahead and get an expression of p game 30 is equal to 10 times p to the 4th times 1 minus p squared. Give me a second and I'll write it up here in this corner. And that brings us to deuce. Now, we're going to break this into 2 pieces. The first thing we're going to do is we're going to figure out what the chances are that we get to deuce. And then once we do that, we're going to figure out the chances of winning deuce. Now, once again, basically this means that both players have reached 40. So you have 40-40, 40 all, and then one player has to win 2 of them in a row in order to win that game. So first, let's figure out what the probability is of getting to 40-40, 40 all, right? So the probability of getting, we'll just say getting to deuce. And that's similar to what we've done before. First of all, how many ways can we do that? Well, once again, you have to have 6 games. 6 games in which 3 are won by you and 3 are won by the opponent in whatever order we're looking at. So this is going to be 6 choose 3. And 6 choose 3 is equal to 20. So whatever we're going to do is we're going to do 20 times whatever probability that we end up with. Well, p cubed is the probability of the 3 games you're going to win. And then 1 minus p cubed are the 3 games your opponent is going to win. And so this is the probability of just getting to deuce. Now comes the hard part, figuring out what the probability is of you winning deuce. So we've got the probability of winning deuce. So we've already gotten to the both opponents have 3 points apiece. So the probability of winning deuce, there are actually 4 options. The first option is that you win 2 points. 2 points in a row. Just bam, bam, all right? And that is p squared, right? Then there's the probability that your opponent wins 2 points. What is that? That probability is 1 minus p squared. Now, we're actually not going to worry too much about this one. But what about the middle case? The middle case says each wins a point. Well, it turns out that there's 2 ways you could do that. The first way that you could do that is if you won and then your opponent won. The second way that it could be done is your opponent wins and then you win. So the probability of that happening, once again, there are 2 ways that you can do it, and then we multiply that by your probability of winning a point times your opponent's probability of winning a point. All right? So this one right here, this is actually a very important probability here. It is the probability of returning to deuce. In other words, getting back to this state right here. And in fact, it could go over and over again for an extended period of time. So each player wins a point, means there's 2 options times your probability that you win times the probability that they're going to win. And what's going to end up happening is you're going to come back into this probability until you win the 2 points or your opponent wins the 2 points. So the probability, this is I'm going to write this out. So the probability of you winning deuce can happen one of two ways. It can either happen by you winning 2 points straight off, or you go back into deuce, win with 2 points straight off, or going back into deuce again and winning 2 points straight off, and so forth. So the way this is going to work is I'm going to say the probability of you winning deuce or the probability of winning deuce. Yes, I know. I've got that on both sides of the expression now. The probability of winning deuce times the probability of returning to deuce. All right, let me try this one more time real quick. If we go into deuce, then you can win it by winning 2 points right in a row, or you can win it by returning back to deuce and multiplying that by the probability of winning deuce. Well, I have the expression for returning to deuce. Remember, that is just p times 1 minus p, and there were two ways to do that. What I don't have is winning deuce. So we are going to solve for the probability of winning deuce. Basically what we have is the probability of winning deuce times 1 minus 2p 1 minus p is equal to p squared. So what I did, all I did was I brought this over to this side of the expression. And when I did that, what I got was the probability of winning deuce times 1 minus the probability of returning to deuce. That's what's substituted in here. Remember, the probability of returning to deuce is this 2 times p times 1 minus p. All right, so I solved for that expression, and whenever I solve again, I get the probability of winning deuce is equal to p squared divided by 1 minus 2p times 1 minus p. All right? And so there's our probability of winning deuce, which means that I can figure out what my probability of winning the game is if we get to deuce. Now, I'm going to erase a little bit of this. Just write that down in your notes. We'll keep track of it. So by solving for winning deuce, what I get is that winning deuce after I got to deuce is p squared divided by 1 minus 2p 1 minus p. So the probability of winning a game through deuce is the probability of getting to deuce, 20 times p cubed times 1 minus p cubed, times the probability of winning deuce, which is p squared over 1 minus 2p times 1 minus p. So let's go ahead and put this whole thing together. And so what we get is the probability, sorry about this, of winning with deuce is equal to, and once again, that's the probability of getting to deuce. So we have 20 p cubed times 1 minus p cubed, and then times winning deuce. So that ends up being over 1 minus 2p 1 minus p. And then we have in the numerator, we change this p cubed, since we're multiplying times p squared, to times p to the 5th. So you substitute in the numbers and you get 20 times 0.55 to the 5th times 0.45 cubed over 1 minus 2 times 0.55 times 0.45. And that will give you, well, I can't do this math in my head. I'm going to have to work this out. And we've got that equals 0.1816. Now, it seems like, well, 0.55 probability of winning. Well, this whole expression right here doesn't represent the probability of winning. It represents the probability of winning by getting to deuce and winning with deuce. We add the, that's not right, is it? I've got an error up here. This actually should be 0 point. That would have been great odds. What we're talking about odds that are a little bit different than this. So what we've got are the probability of winning game love. That's 0.0915. Then the probability of game 15, that's 0.1647. And then the probability of winning game 30, 0.1853. And then the probability of getting to deuce and winning deuce is 0.1816. Well, what is our overall probability of winning the game? Well, it's the sum of all of these. So it becomes, so the probability of a win is equal to 0.0915 plus 0.1647 plus 0.1853 plus 0.1816, which is equal to 0.6231. So if you have a probability of winning a point as 0.55, you have a probability of winning the game of 0.6231 or 62.31%. Now, the interesting thing is that if you look at a probability of 0.45, then your probability of win, it should be equal to 1 minus this. And it turns out it is. So your probability is going to be 0.3768 or 3769. There was some rounding error there. And so your probability is exact, if you have 0.45 probability of winning a point, your chances of winning the game are 37.68%. But your probability, if you have 0.5 probability of winning a point and you go through exactly the same process, you're going to see that your probability of a win is going to equal 0.5, which is what you'd expect. If you have a 50-50 chance of winning each point, you also have a 50-50 chance of winning the game. But what about if your probability is, I don't know, how about 0.6? So we'll increase it just 5% above the numbers that we were calculating. Your probability of a win is going to equal 0.7358. So just by increasing your chance of winning a point by 5%, you jump over 10%. You jump about 11% in terms of your chance of winning a game. If you jump that up to 0.7, then your probability of a win becomes 90.8%. Pretty significant improvement, wouldn't you say? So there you go. A long sloth through figuring out the probability of winning a tennis game based on the probability of winning a single point. You can use this same process in order to figure out how much to win a game, a set, and a match.